Hello and welcome to Research Matters podcasts. Today Aishwarya Viswamitra, will give you a summary of science stories that were published during the week on Research Matters. In your weekly dose of Indian science news today, I cover stories on genetics, engineering, and health. Given that hypertension is the most prevalent chronic ailment in India, the term high blood pressure is not new to us. When a person's blood pressure exceeds the healthy limit, which is about 100 to 130 millimeters of mercury systolic and 60 to 80 millimeters of mercury diastolic pressure, the condition is called hypertension. Since there are no symptoms, hypertension is difficult to diagnose. However, if left undiagnosed, it can cause more serious ailments like cardiovascular disease. Healthy lifestyle changes like avoiding stress and practicing relaxation techniques, along with taking medications, are commonly used to reduce blood pressure. This sounds logical, right? But what if I told you that listening to Indian classical music might alleviate hypertension too? In a first of its kind study, a team of Indian researchers from SSN College of Engineering and Satyabhama College of Nursing, Chennai, has tested exactly that. The researchers chose Raga Malkauns, an ancient raga from Hindustani classical music, which has Raga Hindolam as its Carnatic equivalent. This is what it sounds like when played on the violin. Sounds soulful yet pleasant, doesn't it? The authors of the study recorded a 15-minute long audio clip of the sitar-rendered Hindolam in a professional studio for their experiments. About 200 elderly hypertensive participants were segregated into two groups, where in one, the individuals only took medications, and in the other, the individuals were made to listen to the recorded music daily in the evening for a whole month, along with medication. They found that the participants in the group that listened to music had a lower mean arterial pressure than those from the other group after the month. This may be due to the music-assisted activation of the parasympathetic nervous system, which in turn decreases the heart rate. The researchers are now working on extending their analysis to another 6 months. Continuing with the topic of a healthier lifestyle, do you remember playing outside as a child? Whether it was gully cricket or neighborhood football, studies have shown that an active lifestyle adopted early on in life improves the health of the heart, muscles, and bones, and helps maintain a healthy weight in the future. Unfortunately, a new study by researchers at the World Health Organization (WHO) found that 4 out of 5 adolescents aren't as physically active as they ought to be in 2016. In India, about 3 in 4 adolescents were found to be physically inactive in 2016. Better than Singapore and South Korea, but not as good as Bangladesh. Alas, across all regions, girls were less physically active than boys. The level of inactivity in boys has seen a rapid decline since 2001, from 4 in 5 to 3 in 4. In countries like India, boys are kept active by engaging by playing sports in their local communities like cricket. Girls, on the other hand, are kept active through domestic chores and other activities that support the family. The researchers think that this level of inactivity may be due to kids these days focusing more on academic achievements than physical education and sports. Young people have the right to play and should be provided with the opportunities to realize their right to physical and mental health and well-being, said one of the researchers. And with the health of the future generations at stake, it's time for policymakers and stakeholders to act. Let's move from exercising to eating. Bananas are nutritionally rich, delicious fruits, widely cultivated across the world. But growing bananas isn't that simple. Due to pests and diseases, farmers in India experience severe losses. In a recent study, researchers from the USA, Democratic Republic of Congo, Uganda, Ethiopia, and India have developed a banana pest detection app on your smartphone powered by artificial intelligence. Pretty cool, right? The developed AI-based app can diagnose 5 of the commonly found banana diseases: Xanthomonas wilt, Fusarium wilt, black sigatoka, yellow sigatoka, and bunchy top. It was trained to do this through pre-screened images of affected plants. An AI-based algorithm is then used to train the system to detect the pest using features present in those pre-screened images. Pretty much like how Facebook can automatically recognize photos of you and your friends. Not only does it show which disease is probably infecting the bananas, it even gives recommendations on to see what control measures the farmers can take for that particular pest or disease. Now that the technology is ready, the researchers are engaged in taking this to their intended users, the farmers. Jumping from fruits to roots. Did you know that Meghalaya has rock-solid, centuries-old root bridges? Some are as old as 250 years. These bridges have been built out of the aerial roots of strangler figs and have endured floods, earthquakes, landslides, and fires. In a recent study, researchers from Germany and the USA have tried to understand the morphology and structure of these root bridges. The Khasi and Jaintia people build these bridges by planting a rubber fig tree on one bank of the river. When aerial roots develop, they grow downwards in the air. To make the bridges, they are wound around a bamboo structure and directed across the bank. On the other side, the roots are implanted into the ground. When the aerial roots reach the ground, due to mechanical stress, they produce something called tension wood, which essentially shortens and thickens the root. The tension wood in turn presses neighboring roots with excessive force, resulting in something called inosculation, a phenomenon where the roots intertwine with each other and grow together. Daughter roots develop from aerial roots over time, which are again wound similarly by generations of people, further strengthening the bridge. Most of the bridges are well maintained by members of the village communities, who regularly remove mosses on the bridge, prune and tie the roots, and the researchers believe that this practice of users tending to its maintenance over many years, along with the traditional techniques of the Khasi and Jaintia people, can be integrated into our present-day building structures. Plus, given that the global climate is getting warmer, these kind of bridge structures may also help build cooler cities when integrated into buildings. However, it's important to note that due to the influx of tourists, there has been an increased load on the bridges, which is more than what they were built for. Additionally, in some regions, parts of the roots are either cut, damaged, or overlaid with concrete, destroying the structure. In order to preserve these bridges, we need to find a way to balance conservation, scientific research, and sustainable tourism. The living root bridges are a treasure trove of traditional architectural knowledge that should be fostered for a better future for all. Speaking of intertwining structures, let's talk about DNA. In particular, its unwinding. When a cell divides, the two strands of the DNA have to be unwound from each other so that they can be replicated. If you've ever tried to unwind two interwoven strands with their ends fixed, you know that tension and torsion are created elsewhere in the strands. To prevent this from happening during DNA replication, enzymes called topoisomerases cut one or both strands, throw one strand around the other, and then reseal it to relieve the tension. In a recent study, researchers from the Indian Institute of Science and Jawaharlal Nehru Centre for Advanced Scientific Research, Bengaluru, have explored the working of topoisomerases in the DNA of the bacteria Mycobacterium smegmatis. Since DNA in bacteria is a closed ring, copying it into another ring leaves the two circles entangled with each other. So, they found that topoisomerase enzymes cut the molecules, pass one through the other, and separate them. The study found that the topoisomerase enzyme also played a role in DNA transcription. DNA transcription is a process where the two strands are unwound and copied into an RNA molecule by an enzyme called RNA polymerase. It was found that the topoisomerase in Mycobacterium tuberculosis is activated and triggered into action at the same time that the RNA polymerase is spurred into active transcription. It then alleviates the tension in the DNA strands, just like in DNA replication. The approaches used to map topoisomerase activity were so novel that they can be replicated to understand the role of these enzymes in other organisms, if you know what I mean. Thank you for listening to this episode of Research Matters podcast. See you next weekend. For more such podcasts and news, please log on to www.researchmatters.in.